Okay, to recording. Everyone transcription for the moment. Let me share my screen. Okay. Please tell me if you can see the screen.
Yes, ma'am, we can.
So as I promised on the last discussion class, we'll start with question 10 now. Question 10. Did anyone find a problem? Did anyone find question 10 is a problem for those who were not in the discussion class last week, the previous week? That other week? Yes, no? Hello?
I managed to watch the recording, so I think I caught most of the line. It's the line graph, yes?
Yes.
No? Yeah, I think I caught most of it. I can't speak for others, but yeah.
Okay, so for those who were in the class, for those who were in the discussion class, you noticed that what we covered actually covered what's this? It actually covered question 10 of assignment 2. So I'll just go through question 10 of assignment 2 quickly, and then we'll just not quickly, but it's step by step. So can you see question 10? That was 11 marks. Something like this will be in the exam, would definitely be in the exam. So from our discussion class, we did talk about the different forms of the parabola. And in this one, you'll notice that it's actually a vertex form. If you remember, what did we say about the vertex form? So the vertex form is represented by g of x a x minus p squared plus q. Can you guys see that? Hello?
Yes, ma'am. Yes, ma'am.
So this is, I think, it's the third form that we introduced in the discussion class. So from the vertex form, it means, so let me go to, so we said that there are 3 forms, right? We said y is equals to, okay, I don't know what's going on now. Sorry about that. Okay, I need to fix that. Sorry. Okay. So from the previous, okay. So from the previous discussion class, we said we have 3 forms. We have y, ax squared plus bx plus c. That's the standard form of the parabola. And then number 2, we have y equals to ax minus x1 and then x minus x2, where x1 and x2 are actually the x-intercept of the parabola. And then number 3, we have the vertex form, which is ax minus p squared plus q. So in the exam, you'll be given one of these equations, whether your parabola will be in the vertex form, standard form, or the x-intercept form. So then you also need to be able to analyze the graphs, or if I give you an equation, you'll be able to identify which graph. Remember that the exam will be multiple choice. So it means you have to know how to draw the graph and also analyze the graph. Now in assignment 2, we're actually analyzing the graph, meaning that we are given, so here likely for us, we are given the equation g of x, which is this one here, and we are asked to find certain points in the graph. Now, before you find certain points in the graph, you look at the graph and try to analyze it. You'll notice, as we said, A is where the parabola cuts the x-intercept, the x-axis. So it means that A is an x-intercept. And then B is also where the parabola cuts the what? The x-axis. So B is also the x-intercept. Now C is where the parabola what? Cuts the y-axis. That is the y-intercept. And then E, what did we say E was?
It's our
Turning point.
What is another name for it? If they didn't say turning point, what did they say it is?
It's a vertex.
Thank you. It's a vertex. So E is a turning point, or you can say the vertex of some different Very much. Thank you. So we said E is the turning point or the vertex of a parabola. Now, lucky for us, we have the equation with it here. Okay, sorry, let me do this. So lucky for us, we have the equation g of x equals to x minus 4 squared plus what? Plus 9, if I'm not mistaken. Plus 9, minus 9. Guys, please help me if I make a mistake. So we have minus 9, right? So now this is the vertex form that we are given, and we're also given this particular parabola over here, which is this one over here. So in our case, if we want to find the value of A, we'll notice that the value of A is actually positive. And in this case, it means that A is positive. It means that we'll be having a smiley face of a parabola. As we said, A greater than 0, it means that we have a smiley face. And in our case, A is equals to 1, because just before the brackets, we notice that A is equals to 1. Just also looking at the equation, we say this is a vertex form, meaning that if we have P and Q, the turning point will be given by P and Q. In this case, the turning point will be given by what? Guys? Hello? Anyone?
It's 4, positive 4, and negative 9.
Why not negative 4?
Because of is in the bracket is x minus 4 is equals to 0, then it's going to be x is equals to positive 4.
Thank you very much. Remember what we said. If you are given the vertex form, the P value will be whatever is in the bracket here. So that will be x minus 4 equated to 0. Therefore, x is equals to what? Is equals to 4. So it means that our turning point is 4 and minus 4. So let's go to the question. The first question says, find M, P, and Q and write down the equation of F. So we go to F, right? So this is F. F is equals to, let me choose a different color. They say F is equals to, F of X is equals to M, absolute value of X minus P plus Q. Remember what we said? We said that the P and Q in the, before that, what equation does this represent? Which graph here? Before I go to explaining that part. Which graph does f of x represent?
Line graph, man.
The,
Line graph.
why do you say the line graph?
I'm assuming because there's no exponents in the absolute value, like it's a straight line graph.
Okay. But then we do not have a line graph here.
Oh, okay.
Anyone who attended the or looked at the video, what is this? What does this represent? Which graph?
I think it's a linear graph because of the gradient.
It is a linear graph, but look at this. This whole graph, what does it represent? As soon as it has an absolute value of x, then it changes. It's no longer a linear graph. It's an absolute value function because of these lines here. Do you see that? So if you have y is equals to x, that's a line graph. But as soon as you have y absolute value of x, that's an absolute value function. Are we all clear there?
Yes, ma'am.
Thank you. So meaning that this is an absolute value function. It's actually the function, this function over here that is facing downwards, the one that I'm just drawing over that is facing downwards. and that is called the absolute value function. So in this case, they ask us to find the value of P, the value of Q, and the value of M. Remember what I said, this looks like the vertex form of a parabola, except that there's no square in it. So meaning that if we're finding the vertex of an absolute value function, we'll just apply the same way that we do with with the vertex of a parabola. So can anyone tell me, by looking at what we are given, what is the value of P and what is the value of Q? Hello? Guys? Hello? Guys, should I skip the question? Because no one is saying anything. Hello?
Ma'am, X is equals to, P is equals to 4 and Q is equals to 9.
But then that's for the parabola. We want the one for the absolute value function. Remember, we are looking at this part, not this one. We are looking at f of x. You are right, but we're looking at f of x. Guys, try it. Please try. What did we say P? What did we say P and Q represent?
They represent the vertex, ma'am.
Yes. So in this absolute value function, which one is the vertex? Is it A? Is it B? Is it C? Is it F? By looking at this graph, which one is the vertex? From
D.
A, B, C, D. D is the vertex,
D is the vertex.
right? So now, are we given D?
Yes, it's 4 and 9.
Thank you. D is what? Is 4
4 and 9.
and 9. So meaning that our P is equals to what? Our P is equals to 4 and our Q is equals to 9.
Yes.
Does it make sense now?
Yes.
Thank you. So now that we have this, let's substitute to f of x. So we have f of x is equals to m absolute value x minus p plus q. So meaning that this will be, let's make it y is equals to m. We don't know m, but we do know p. We said that if outside is what is positive p, it means that inside should be what? Should be negative. Thank you. Negative what? Negative p. So this will be negative 4 plus 9. Are we done there?
Yes.
No, ma'am, we still need n.
Thank you. We still need m, the gradient. Now, how do we find m? We go again and look for any other point on the what's this? On the graph, right? Now,
yes.
the other point that the graph touches, the whatever other point. Okay, so let me say the other points that we have is A, B, D, but we can't use D, remember? So we have A, we have B, we have F. Which point can we use there?
F.
Why?
F, ma'am.
Why?
Because we are given the coordinate.
We are given the coordinate which is in the information given. So they say that F is negative 3 and 0 and 3. So we take that point and we substitute.
F of X.
Okay, someone would you please? So now our F we are given, it's this point here, which is the y-intercept of the absolute value function. Now we substitute. So we know that in this value of f here, our x is 0. So this x here is 0. So where we see x, we put 0. So let's say m 0 minus 4 plus 9. And where we see y, we put negative 3.
-3,
Negative.
yeah.
Thank you. Now, okay, let me write it like this. So this is m absolute value of negative 4 plus 9 equals to negative 3. What is an absolute value of a number? What is an absolute value of 2?
Is -2, ma'am.
Okay. Second answer. I need 3 answers. Then we take the average of the answers. What is an absolute value of negative of 2?
Oh, 2.
Yes.
Isn't it -2?
You have a calculator there. I know I said that we are not using a calculator in the module.
Okay.
Take an absolute value of 2 and take an absolute value of negative 2. And tell me what you get.
Isn't it a positive 2 and a negative 2?
Okay. Try again. Take the absolute value. Take a calculator. Put absolute value. Or Google, what is an absolute value of negative 2? Or what is an absolute value of 2?
Okay.
Ma'am, aren't they both 2?
Why?
I don't really know.
I want you to know.
Okay,
want you
let me
to
try and
know.
figure it out.
Because the
Okay.
absolute value isn't it the distance from 0 until that number that you're looking for?
Allah. Hence there.
So it
the
makes sense
distance
for it.
part. Have you ever traveled a negative distance?
No.
Thank you. So it will always be what?
2.
Positive. So it means that the absolute value of negative 4 is equals to what? Is 4. So this will be
4.
4m plus 9 equals to negative 3. So then this will be 4m equals to negative 3, negative 9. So then this will be 4m equals to 3, 6, 9, 12, negative 12 divided by 4, divided by 4. Okay, I'm showing some solutions here, but it's fine because we've covered that. So m is equals to negative 3. Now our m is equals to negative 3. Does it make sense? What if I say m is equals to positive 3? Would you agree with me?
No.
No.
Why?
No,
Because the graph
because
is looking downwards.
Thank you.
yes.
So remember we said if m is equals to if m is greater than 0, meaning that it's positive, your absolute value function will face up. And if m is less than 0, meaning it's negative, your absolute value function will definitely face down. So now that we have found our m, and then it means this will be equals to negative 3x minus 4 plus what? Plus 9. Why am I saying Q? So this will be plus 9. Are we all sorted with this question?
Yes.
Yes, ma'am.
The solution. Okay, we are all correct. Thank you very much. Now, what is the next question? The next question wants you to write down the coordinates of E. What is E? Remember, you can't write down the coordinates of something that you do not know. What is E?
E is the
What's that on your
vertex
graph?
The vertex
Of what? Because there are two graphs which have vertex.
of the parabola.
of g of x.
Thank you. So give me the answer then.
Okay, turning point. It's y equals to
9. G is going to be 4 and a negative 9.
Do we agree? Me, I disagree.
agree.
But me disagreeing doesn't mean I'm right. Do you agree?
I agree.
Okay. Who doesn't understand how they found it? It's very important to me. Who doesn't understand? Remember, we will not all be together in the exam. Who
Mm.
doesn't understand? Who doesn't understand how we found e to be 4 and -9? Okay, means you
No
all
one.
understand.
Yes.
So, but I'll still explain it for those. I don't know if those who didn't attend, I don't know if they understand or not. So g of x is equal to x minus 4 squared minus 9. We said that this is in a vertex form. So meaning that the P and the Q is the turning point of a parabola. So we said that the value inside the bracket is x minus 4 must be equated to 0. Therefore, x is equal to 4. So that's where we got the 4. And then the 9 is exactly the same. We just put it. That's where we got the 4 and minus 4. Where's my E? I hope I wrote the right answer. There we go. Calculate the coordinates. So the next question says, calculate the coordinates of A. Ooh la la, what is A? We go to the graph. Remember, you can't calculate something that you do not know. So you go to the graph. What is A?
A is 1.
Alala, how did you calculate it? Sophie just looked at it, magicians.
Yeah, I just looked at it.
Isn't
If I
it
say A is
18?
25,
Okay, A equals the equation.
what is
Mm,
A?
A
Okay,
is our x-intercept, ma'am,
of what?
of our parabola g
And
of x, and of our absolute fraction.
okay. Now there's something I want you to notice here, right? A is the x-intercept and B is the x-intercept, right? But then it is also okay, so A is the x-intercept of the absolute value function. So meaning, okay, before that, A is the absolute x-intercept of the absolute value function. And also A and B is also the x-intercept of the absolute value function. But the other thing is also where the two graphs intersect, the point of intersection. So here it is easy to calculate A and B by using a parabola or one of the graphs. So let's use a parabola to calculate A and B. But if then I ask you a point of intersection in the exam, you have to then equate the two graphs and solve.
Okay.
Does it make sense?
Yes.
Yes. Because if A and B was here, and this is where the graphs was intersecting, we're not going to say these are the x-intercept of the parabola. Do you see that? So let's say our absolute value was like this. Then you will actually calculate the point of intersection of the two graphs. So it means you say f of x is equals to g of x. That's what you were going to say. But we are not there. We can look at one of the past exam question papers when we did it. So now let's calculate. We know A and B are the x-intercept of the parabola. We know our parabola. I don't know why my pen is doing this. So g of x is equals to x minus 4 squared minus 9. We know that our A and B is at x-intercept. So we let y is equals to 0. And I will not ask why we let y equals to 0, because we did mention that in the first discussion class. So we just continue. We substitute. So let's write this as y is equals to x minus 4 squared minus 9. Where we see why we put 0. If you want, you can expand the brackets. Basically, what I mean by expanding the brackets, I'm saying you can say x squared minus 8x plus 16 minus 9. You can do that if you want, so that you factorize. But for me here, I'll just continue like this. Now let's write it nicely. So let's write x minus 4 squared minus 9 is equals to 0. So then we take, what's this, 9 to the other side. So this would be x minus 4 squared is equals to 9. Then we take the square root both sides. Are we all okay there when we take the square root both sides?
Yes. Yes.
because taking the square root, doing this, so the square root of a is the same as a to the power of half. So what we are saying is here, we are taking the square root. So we are taking the square root of x minus 4 squared. We are taking the square root this side. Remember what we said, what you do on the right hand side, you also do what you do on the left hand side, you also do on the right hand side. So this is the same as x minus 4 squared to the power of half. This is the same as 3 squared to the power of half, right? Now, exponential laws, this times this gives you 1, so it's x minus 4, which is, but remember when you take a square root, you say plus or minus 3. So that's where we are. So let's take the square root both sides. We square both sides. This is our rough work. We square both sides. So this will be x minus 4 squared equals to square root of 9. So then this will be x minus 4 equals to plus or minus 3. Are we all sorted there?
Yes.
Yes.
Thank you. So since we have plus or minus 3, so then x minus 4 is equals to plus 3, or x minus 4 is equals to minus 3. Then we simplify. So x is equals to 3 plus 4, or x is equals to minus 3 plus 4. So x is equals to 7, or x is equals to 1. So how do I decide? Okay, so I have 4 and 1 here. How do I decide? Please help me.
The lowest one is the first one, and then the highest number is the last one.
What if the graph was on the other side?
I think the same applies. Okay, the lowest one, which is going to be like a -7, will be on the left, and then the highest number, which might be -1, will be closer to the origin.
Thank you. We know here it's 0. Here it's 0. Most definitely, you cannot say 0, 7, -0, 7, 5, 3, 2, 1. No. So definitely this will be 1 and this will be 7. So meaning that A in this case will be what? Will be 0 and 1. And B, because it's also an x-intercept, will be what? Will be 0 and 7. No.
1 and
Am I
0
right?
and 7 and 0. No, ma'am.
Okay, tell me why.
Other way around.
Thank you. Because these are x values and not y values. Thank you. So it means that A will be 1 and 0, and B will be 7 and 0. Let's see. You see here, I actually did what I said. Expand and so forth, and get answers. So the x coordinate, okay, we did that. I don't want to show you solutions. This one, M is a reflection of C in the axis of symmetry of G of X. Write down the coordinates of M. There are words there. There are words there. For you to answer this, there are words there. Is the reflection axis of symmetry? Someone remind me what is the axis of symmetry or the line of symmetry?
Isn't it y equals to x?
What is our discussion? What did we say in our discussion class? Don't pass crime and forget. There's also an exam, remember. What is our axis of symmetry or the line of symmetry? Anyone? Please help. What did we say? It means we know, I think it means we know 10.5, so I can move on, right? Yeah, think
No,
we can,
thanks, ma'am. Oh,
okay. Tell me what it is then. What is the line of symmetry or axis of symmetry?
Isn't it the line where y is equals to x?
The line where y is equals to x. So when you draw it, it gives you point, negative, positive, negative, positive. So this is the line of y equals to x. That's the line of y equals to x. So what is the axis of symmetry? Guys, did you watch the previous video? Honest, let's be honest now.
Ma'am, can you please repeat the question?
What is the axis of symmetry? If I say axis of symmetry, or line of symmetry,
But it's where y is equals to x, right?
the line y equals to x, I drew the line y equals to x. Do we all agree?
No, ma'am, it's a line that cuts a parabola into two. It's a vertical line.
Okay. I give you 3 out of 5. Please give me a 5 out of 5. Continue your statement. Repeat your statement, but not repeat it. Correct your statement. It is the line that does what?
That cuts a parabola into two, which is vertical.
So if you look at in the mirror, you'll see half of yourself.
No, ma'am, I see full.
You see full. But what do you see?
how about
Exactly
the
yourself or
opposite?
someone else?
You see a
Myself.
reflection,
Yes.
a reflection of yourself.
So, yes, the reflection of yourself. So what is the line of symmetry then? Or axis of symmetry? It's the line that what?
Cuts both into equal parts.
Yes. So
Cuts the graph
basically,
into
it
equal
means
parts.
that if you draw a straight line here and you cut this parabola, even the absolute value function, you can see that, and cut this parabola, this part here is the same as this part over there. So meaning that the distance from here to the line here is exactly the same, the distance from here to the line here. Do you see that? Does it make sense? Or should I repeat?
Yes, ma'am.
Yes, ma'am, it does.
It does make sense, right?
Yes.
So now, okay. So now what are they saying in this question? In this question, let me slow down slowly. In this question, they say that M is the reflection of C in the axis of symmetry of G. Write down the coordinates of M. So meaning that M will be here. This is M. This is what my heart says, tells me. Am I correct? Who agrees with me or not? Yes, no?
I disagree.
Who else
Same here.
disagrees and give me a same here? Okay, give me why you are disagreeing.
I'm disagreeing because it said in the question it said it's C at C. The reflection is at C on the axis of symmetry of GX, so it should be a little bit higher
Yeah.
on the parabola.
So is it corresponding to C or not? On the other side.
No.
It should be corresponding to C, but it's not.
Okay. So what are you saying? So meaning that how do I do it then? Would it be here? You said higher. Would it be here?
No, it would be
No.
in line with C.
We're in line with
Thank
C, yes.
Thank you. It will be in the Y. No. Yes. It will cut.
Yes,
so
why?
it will be a line that cuts y, it also has to cut m. So meaning that if I draw a line that cuts the value of c there, it also has to cut what? It also has to cut m. So m is equals to there. Do you all agree?
Yes.
So what did, before we agree on something, we said c is what? 0 and what? What is c?
0 and
7.
7. Are we all okay why we got the 7?
okay, yes.
Okay, but I'll still explain it for those who are not. Yeah. So because c is the y-intercept of the graph x minus 4 squared minus 9. And we know c is the y-intercept, meaning that x, we let x equals to, let x is equals to 0. So then we say y is equals to 0 minus 4 squared minus 9. So then y is equals to negative 4 to the power of 2. This is equals to 16 minus 9. This is y equals to 7. That's how we got the 7 day. For those who did not understand, remember, guys, don't say you understand and then you don't understand. It's important that I explain it. If you don't understand, it's fine. I'll explain it. This is your time. Flourish. Okay. So now it means that we know that our m, it's a y coordinate, will also be what? Will also be 7. So what will be its x coordinate? What will be its x coordinate? Anyone? Okay. Remember what we said. The axis of symmetry cuts the graphs, the parabola into 2 equal halves, such that if I move from A, remember the parabola cuts here, right? If I move from A till this point over there, right? It's exactly the same as this point here to that point there. But where is C? C is here, right?
Yes.
Now C is there. So if I move from this point to that point over there, is the same as, so M is there. So M will be somewhere here. It's the same as moving from here to there. Do you all agree?
Yes.
Yes,
So
ma'am.
from here to there, how many units did I move?
4.
4 units. Why? Where do you see that 4? Because there's no 4 written here.
Ma'am, what is the vertex point of the parabola again?
There we go. It is 4 and negative 9.
9.
9.
And then 4 and 9. So meaning that the x value, this line of symmetry, its x is equals to 4. That's the equation of our line of symmetry. Do you see that? So meaning that from here to here is 4. So it means from here to here is also what?
4.
So do the math.
That's 8.
8.
Okay.
Makes sense, right?
Yes.
Thank you. So we're done with question 10. I'm not repeating question 10 even for the exam. If you didn't get it, please make sure you watch the video again because we need to go to the other assignments.
Morning, ma'am.
Morning.
I
I recognize the voice. Is it Ryan?
No, it's not. It's Patu Chezo.
Yes.
I want to
Okay.
find out the session will be recorded because I'm currently still at work and I can't attend full time.
We are recording the session. I hope we are recording the session. Let me see. Yes, we are recording the session because I think it will be a big video, so it means we'll put it there on the on YouTube format for Thinking.
All right. Thank you, ma'am.
You're welcome. Okay, guys, if you want to talk, just talk because I can't see you the side. I only see the documents. Okay. Are we all sorted there?
Yes, ma'am.
Thank you. Now, I want us to just go through question 1 very quickly. It says, determine the statement if it is true or false. If it is true, explain why. If it is false, explain why. Or give an example that disproves the statement. Now, you say in maths, right? If you have a statement and you find what you call a counterexample, right? And then you disprove that, then it means the statement is not true for everything, unless on that part, unless they give you a domain. For example, let's say I say all boys like green. Is my statement true? Hello? If I say all boys, they like green, is my statement true?
No, it's your opinion.
Why are you saying no? Because you said no
It's your
so
opinion.
confidently. It means that, okay, why are you saying that?
Because not all boys like green.
It's because you ask someone and you know there's a boy who likes blue, right?
Yes.
There we go. So with maths also applies like that. If you're given a statement and then you find a counterexample, then you can say no, the statement is false, because if you give this example, then the statement is false. As she said, if I say all boys are what? All boys are like green, and you know that your brother likes blue, then you can say, but my brother likes blue. So it means that your statement is what? Is incorrect. Now here's the statement. Oh, no answers, please. It says if f is a function, then s plus t, f of s plus t is equals to f of s plus f of t. False or true? What did you write? True or false? Hello? True or false? I want to ask you why. I promise I want to ask you why. True or false? Yes?
True,
False.
True.
true.
There's another false. Can we please have 3 answers that we take the average? Or majority?
False.
False.
True.
Ah, okay. One last answer.
False.
True.
Guys, you're giving me true, false, and you're all being equal now. Okay, those who say true, can one person explain? I know I said I will not ask you why, but if you want to, can you explain why you say true? And if you want to, can you explain why you say false? And please do not keep quiet. Okay, let me do this one.
Pardon me,
Yes.
I think the F mem is multiplying what is inside the bracket. So F multiplying S will be F times S plus F times T.
Remember what I said. If you are given a statement and you are supposed to say whether it's true or false, you look for an example that disproves the statement. If you cannot find an example, which we call in maths a counterexample, it means that that statement is true. So can we find one example? There can be one, there can be many. Can we find one example that shows that this statement is false? If we can't find the example, then the statement is true. So what we do, you say, okay, fine, let me choose let's say let f of x equals to x to the power of 3, right? And then let's say s is equals to 1. And then we say t is equals to 2. Now, we say f of s plus t. What do we get? We get that s plus t to the power of 3, which is what? Okay, so s is 1, t is 2 to the power of 3. So this gives us what?
9.
3 to the power of 3. 27, right?
Oh, yes.
Then we have f of s, which is equals to s to the power of 3, which is equals to 1 to the power of 3 is equals to 1. And we have f of t is equals to t to the power of 3, which is equals to 2 to the power of 3, which is equals to 8. Now let me choose a different color because I just want to write here on top. So let's go up here. So then it means that f of s plus t is equals to what? Is equals to 27. But f of s and plus f of t is equals to 1 plus 8, which is equals to 9. So it is not true that if f is a function, they didn't specify which function. They said f is a function. It means that s of t is equal to 27, but then it's not equals to f of s plus f of t, which is equals to 9. So it means our statement is what?
Not true.
Not true. So you can also try other functions as f of x is equals to x squared. You can try them and see, right? As long as you can find one example that shows that this statement is false, then it means that the statement is false. So find a counterexample. So yes, the statement is false. I gave an example like this, and you could have given another function, a different function, x is equals to 2x, x to the power of whatever. And C. Okay. Yeah, man, I showed you the answer.
Ma'am, may I ask?
Yes.
I have an issue with this one because I believe if we use linear functions, it will be true. But if we use like
yes.
Yeah, so
But
I don't know which one to choose actually.
okay. So can someone explain to him what I said?
Because the equation only describes linear functions, it doesn't describe the other functions. So it only works for linear functions.
Yes. And
Okay.
here they told you that it's a function. They didn't mention a function. So meaning that they are saying, that's the statement that I said as well, all boys like green. If you can find your brother, your boyfriend, your father, or whoever, okay, they're not boys, but they, or let's say all men, if you can find one of them who likes blue, then you're saying, your statement is what? Is incorrect. So if you are given a statement in maths and you can find one counterexample, even just one, doesn't matter if you find 100, but one that shows that that statement is incorrect. It's called a counterexample. If you find that counterexample and shows that statement is incorrect, then you can what? Then you can declare that the statement is false. Yes, for other functions, the statement will be correct. Because if I go around in the community and I say, hi, sir, do you like green? Yes, I'll definitely find someone who's green, who likes green. But if I continue and say, okay, fine, hi, sir, do you like green? I'll also definitely find someone who likes red and doesn't like green. So then it disproves my statement. So meaning that you need to choose, you need to show more than one. Like linear can be okay, but then what about the sine function? F of x is equals to sine x. Do you see that? That is not true. True or false?
What's true or false, ma'am? What question are you asking us? The sign.
1.2, sorry. 1.2.
Okay.
Yes. If f of s is equals to f of t, then definitely s is equals to t. True or false?
False.
False. Can you give me an example that gives that f of s is equals to f of t? So it's saying the y value of s, sorry, the y value that you obtain after substituting s will be the same as the y value you obtain after substituting t. Does that sound familiar? Guys, do you remember parabola? You remember the m function, the y value you got 7. And you substitute the y value there, you got 7. But the x value of c and m were not the same. Hello? Are we all okay? Do you understand? Yes, no?
No, ma'am.
Okay. They're saying that
I'm just trying to work it out.
okay. They're saying that if I substitute, let's say I have f of x, a function, and y is equal to f of x, and I substitute a value s, right, in f of x, I get that. And I substitute another value called t in f of x, and then I get that. These two, if they are equal, let's say this is f of s is equals to f of t, then it means that s is equal to t. Is that true?
Yes, ma'am.
Okay,
Yes, I think
another
it's
answer
yes.
for all functions. Okay, let me go here. Let me just go back here. We said that, okay, in this case, our f of x, this is our f of x, g of x is equal to x minus 4 squared minus 9. Do we agree that if we say c, let c is equals to s, the x value of c, in this case, our x value is 0. If we substitute in g, what do we get? We get 7, right? Now, if we take the y value of m, so let's say the x value of m in this case is equals to 8. Let's call it this t. Do you agree that if I substitute in g, I'll still get 7?
No, ma'am.
No.
Yes, ma'am.
Why are you saying no?
Yes, you will still get 7, ma'am.
That's what we said here on the reflection. You still
You still
get
get
7. But is s equals to t here? Remember we said our s is the x-intercept, is the x coordinate of SC, and here we define our mx is the x coordinate of m. We got 7 here, we got 7 here. But at least is s equals to t. Guys, I don't know if I'm making sense. Hello?
Yes, ma'am. We got the same answers. 7 and
You got-
7.
But
So
the
S is
value
equals to T.
but was s equals to t?
No.
No. Okay, maybe I think my brain is also confused on what I said. Did I confuse anyone?
I'm still lost, ma'am.
Okay, so remember, I want us to go back to our parabola, this one. Remember we said C is equals to 0 and 7, right?
Yes, ma'am.
And we said M is equals to 8 and 7, right?
Yes, ma'am.
So if we say, let's say this value here, we call it S, the X value of C, and we call the X value of T 8, right?
Yes, ma'am.
So S is equals to 0 and T is equals to 8, right?
Yes, ma'am.
We substituted back to the parabola. X minus 4 squared minus 9. If we say g of 0 is equals to 0 minus 4 squared minus 9, we'll get 7, isn't it? And then
Yes, ma'am.
g of 0 is s, sorry. And g of t in this case is 8. So g of 8 if we substitute here, we'll also get 7, meaning that g of s is equals to g of t. But is it true that s is equals to t?
No, ma'am.
Yes, it's not true because s is equals to 0 and t is equals to 8. But this statement is true. So meaning that our statement that we got here is false. Because, where is it? Our statement here is false because we did get the same value of y for s and t, but we didn't get the same value of but s and t were not the same values. So meaning that, let me write it here. Meaning that a parabola can be a good example. For example, if we say sorry. Okay. So if you say let f of x is equals to x squared, right? And we let s is equals to 3 and we let t is equals to -9. Then f of 3, f of s is equals to s to the power of, s squared, then 3 squared is equals to 9, right? And then we say that f of -3 is equals to same squared, which is equals to 9. So f of 3 is equals to f of -3, but t is not equals to s. That's why our statement is false. Because t is t, what is t? Because t is -3 and s is equals to +3. Are we sorted on that one?
Yes, ma'am.
Yes, ma'am.
The next statement. Can you do this? And then I'll give you 2 minutes to do this one. If f is a function, then f of 3 is equals f of 3x is equals to 3 times f of x. True or false? And then you'll tell me why. Few minutes. Let me give you 3 minutes. True or false? True or false? True or false? Or false? Hello? Is the statement true or is the statement false? If no one is answering, then we can skip the question. Guys, discussion is dialogue,
Ma'am,
not me talking to myself. Yes.
ma'am, I would say that it's false.
Okay. What example,
statement
which
is true.
function did you use?
I used a parabola.
Okay. So which is f of x is equals to x squared, right?
Yes, ma'am.
And then what did you do?
Well, I basically substituted 3x into the equation. It gave me 9. Yeah,
Mhm.
9x squared. And then the other side, ma'am, I had a problem. I think I had a problem. I didn't know exactly what to do. I was a bit confused.
Read. What does it say? I know you know.
3 times fx or 3fx.
What does it? Yes. Remember, don't
Means
confuse yourself. It means
uh,
3. You
it's
said 3
basically
times what?
fx.
F of x.
Yes,
What is your f of x?
x squared.
There you go.
So am I right
So,
by saying it's false?
yes, because look at
Okay.
this. F of 3x is 9x squared. 3 times f of x is what? Is x squared, 3x squared. So it means that you're
Yes.
right by saying it's incorrect because this part here is equals to 9x squared and this part here is 3x squared. So this statement cannot be true, not equal. You're right.
Okay. I was just confused about the math around it.
Oh, okay. No, as long as you sorted, that's what matters. Is everyone sorted? Remember, guys,
Yeah. Well,
we're not writing the exam together. So if you keep quiet, it means you're sorted. True or false? A vertical line intersects the graph of a function at most once. True or false? True or false?
ma'am,
Yes.
this one depends on what you look at, but if it's a
Okay.
one-to-one function, I believe it's true.
Those are big words. 1-to-1.
Yes. So a line graph. What else is a one-to-one?
But before that, how do you determine how do you determine it's a one-to-one function?
Kana, what's the thing? It doesn't have more than one x-intercept at a time. Am I making sense?
Let's hold that one. We'll look at it
Okay.
in the next discussion class. And we need to clarify that. We'll look at it in the next discussion class. But it says here, because when you look at one-to-ones, you're looking at the horizontal line test. Do you see that? And here I'm talking about the vertical line intersects the graph of a function at most ones. Guys, are you reading your textbook? Honest truth. Because the questions will be from your textbook, will be like, they might not be exactly the same, but they'll be similar and they will cover work from your textbook, from your study guide, as well as the assignment.
Ma'am, I think the answer is true.
Why?
Because a vertical line is a line that is used to test if a function is a function. If a graph
Okay.
is a function.
Okay. So okay, so what does the vertical line test? Like, give me the statement. What does it say if you remember it? Simple English.
If
If
a
you were telling
vertical if a
yes,
vertical line intersects a graph at least once, that means the graph is a function.
the English. There's one thing that cancels your English. Remember, I said in the exam, if I want to test your knowledge, I'll say the vertical test line intersects the graph. What am I saying? A vertical line intersects the graph of function at most once. A vertical line intersects the graph of the function. The vertical line intersects the graph of the function at least once. The vertical line intersects the graph of a function. It does not intersect the graph of function. Which statement is true? So I talked about the vertical line intersecting the graph. All in all statement, which statement is true? Remember, your exam is a multiple choice. So you need to know if the statement is true. You said something, but it's not completely. Only one word changed the whole thing and made it wrong. Repeat the statement, but remove that word. Anyone, guys?
Ma'am, please repeat your question.
I'm saying that we want to find out if it's true or false. A vertical line intersects the graph of a function at most once. Is it true or false? And you said it's true. And then you said you said the statement. But the statement makes it incorrect because there's one word that made it incorrect. Can someone say it in Zulu or Sotho or Pedi or any other language? Hello? Guys? We're on the vertical line. We can't sit on the vertical line the whole day, guys. We have a lot to. Yes.
It's a function is a relationship between inputs where the inputs and outputs are related to exactly one output point.
Okay. So now I don't want you to put it in words. I want you to talk about the vertical line. Because someone said a vertical line cuts it's a function a graph of a function. What am I saying? What did you say? Please repeat. Sorry. You said at least once. It cuts the graph at
I
least
said
once.
a vertical line is a line that intersects the graph at least once to make it a function.
You see your statement. I want you to say it in your own language.
Assimiline okata hour. I'm done.
No, just try it because there's one word that is making your statement incorrect, which is correct. Your statement is correct partially because there's one word that cancels the whole statement. That's why I'm saying say it in your own language. Function ikata vertical line ikata ing function. Say it, guys. We need to fix this.
Vertical line was a graph or a function.
Ikata ikai.
One.
Haiwan. And your English was incorrect, but your language is correct. Can you correct your statement now?
So a vertical line is a line that cuts a graph once to make it a
Thank
function.
you. Thank you. Because why don't you say at least? I want at least 50. It means you want 50 or 55 or 78. At least. The word at least means that 50 and greater. So once you say a vertical line cuts at least once, it means it cuts it twice, which makes it the statement untrue. Does it make sense now?
Yes.
Thank you. So a vertical line, if you draw a graph like this, what will make it a function is that if you take a vertical line or a ruler and draw them as many as you want, I don't know why they are canceling. As many as you want, they'll cut the graph once. Then we can say this graph is a graph of a function. So they cut them at most once. Do you see the statement at most once? Once you say at least, you are wrong because you mean that it cuts it once, it cuts it twice, and it cuts it 3 times, which is incorrect. So this statement is true. Are we all sorted now? Guys? Are you still there or empty?
Yes, ma'am.
Yes, ma'am.
Thank you. Sometimes it helps to use your own language. Trust me. And if you are multilingual, it's even nice because it might not sound proper in Pedi, but it might sound proper in Sotho, you don't know. So they say that if f of x is a 1-to-1, then the function this is this what? Is equals to that. Can we not do this one? But this is false. The reason why is because there's a statement 1-to-1, and I want us to look at that in the other session. But they are saying that if I have the inverse of a function is the same as 1 over the function, that is not true because if you have, if you have f of x is equals to x squared, x to the power of 3, and the inverse is equals to this over here. So we know 1 over f of x is 1 over x3, which is not the same as the inverse. So this statement is false. So we are done with the statement with 2 questions in the assignment. Are we all okay then?
Yes, ma'am.
Okay, now for your homework, like I said in the discussion class previously, how many of you here? You are 19. Ne? I am expecting, let me just be remote. I'm expecting 10 submissions. Can we agree on that? 10 submissions by end of day tonight. Whether the answer is correct or not, I want 10 submissions out of 19. Then we are having another discussion class. Do you agree?
Okay.
Yes.
Okay, ma'am, can you please repeat that because I just got back now from a different location, so I was not here in I think 15 minutes ago. So can you
Okay.
please repeat what you just said? Yes.
Okay, before that, Makoto. Makoto, are you there? Makoto,
Ma'am?
you are there?
Yes, ma'am, but I didn't hear. Did you say we must submit the question?
Okay, I'll tell you now. The reason why we have this discussion class is because of 3 people like Makoto and Ryan and Tanya who submitted the work last time. So I am saying I want 10 out of 19 submissions. If all 19 submit, it's fine. But I want 10 out of 19 submissions, or I want 10, even those who watch the video later today. By 12 o'clock today, I want 10 submissions of question 2 and question 4 of assignment 2. Does that make sense?
Ma'am, you want us
Yes.
to do basically the questions and then submit them to you?
Yes.
Okay. How do we do this? How do we
So
submit?
basically, you solve them on the piece of paper. You take a screenshot. You email me.
Okay. Okay.
And what's
Yes.
question?
Question 2 and question 4 assignment for assignment 2.
Question 2. Almost 2. Before 12.
Yes. So even if there are other people who will watch this video later, but if they can submit those questions, I want 10. Once I have 10, it means that we are having a next discussion class.
Ma'am, where do we find the videos?
I normally send the link because the videos are big, so I upload them on YouTube and then send the link on the announcement.
Because for the previous two discussions, I wasn't part of them because I didn't see the emails.
Or the first discussion, I didn't record it by mistake. The second discussion, which I call it the first discussion right now, is the one that is uploaded on YouTube. I did put the link under announcement. Please check your announcement. There's also something that I uploaded yesterday because the student asked for, they were struggling with assignment 4, so I uploaded that one, some notes that can help with that particular question. So check your announcement every week. So we all agree, right? You'll tell your friends as well. If I don't get that 10, we don't have a discussion class. Do we agree?
Yes, it's question 2 and question
4.
4. Okay.
Yes. The reason
Okay,
why I'm
thank
saying
you.
question 2 and question 4 is because I want you to go and practice what we have learned today.
Okay.
So now, if we don't finish, I'll give you maybe extra time for tomorrow, but question 2 and question 4. So now let's
Okay.
look at new words. Should
So
I
we
give
send
you
it where?
email?
Email. Okay, no
Yebo.
problem. In a PDF form or?
Any form, as long as I see that you did the work, whether it's a picture
Okay.
or what. Yes, I'll look
Okay,
at the
no
work and
problem.
say, okay, they did the work, they understand. It gives me a clarity of saying, okay, they understand for the exam, so that I continue with the work.
Okay.
Okay, so now there's something that I'm telling you this. This is question 1. It's normally question 1 in most of the exams, previous exams. And if you don't understand it, you will not get it. It's called the domain of a function. It's important that you know how to find the domain of a function. So let's look at that. Should I give you 10 minutes to take a break and then we come back? Because we're starting a new section now.
No.
Okay. Yes, please.
Yes,
Hey, we're
please,
coming
ma'am.
back at 58.
58, 10 minutes.
All right.
Hello, are we back?
Yes, ma'am.
Yes, we are.
Thank you. I see there are 16 people. I hope the other 3 are coming back soon. Okay, so one of the important topics is the domain, and you will notice that for our next session, if we finish this, okay, pause. Let me pause and breathe. We're going to cover the domain and transformation, right, of functions. One of the important things you'll notice is the domain is very important in this module. We look at combinations of functions, what we'll look at next week, right? We also have to be able to find the domain. And if you're given a function, you're able to find the domain. And then if you're going to write the domain, know how to write it in set notation and also know how to write it in an interval notation. I'll show you how now. So this is an example in the textbook. I just forgot what page it is. But we have A equals to, what did it say? So we have, let me choose a different color, maybe f of x is equals to 1 over x minus 4. Can you please help me? What is the domain of this function? But before we start with the domain, what is the domain? Well, let me just explain it. The domain is all possible values of x for which the function is defined, and the range is all possible values of y for which the function is defined. But in this case, I want us to focus on the domain so that we can also do the combination of function next week. So what is the domain for this function? Yes. Try. Guys, you rather try than just keeping quiet. Please try. What is the domain of this function?
Isn't it maybe -4? I'm not sure.
I minus 4.
I'm not sure.
Oh, you know what? Let's leave the domain.
X,
X
Hello?
can I answer? X cannot be equal to +4
Why?
because if it's +4, then your denominator is going to be negative, making it
is going to be
now non-applicable.
I'm still thinking. Okay, let's just think of moving this section to next week's session because I want us to cover the transformation and finish with it. So can we please put a hold on this one and then we'll do it next week because we need the domain of the function next week for combinations of functions. Is that okay with you guys? Hello?
Can you please
Okay.
repeat them?
I'm saying that we'll leave this section for next week because we'll need this for next week. So I can't repeat things. I can't repeat things for the time because we have to cover everything.
Okay.
Yeah.
Okay.
What am I doing now? So instead, let's do transformation. So transformation is chapter 2, section 2.6, transformation of function, page 198. Can you please mute a little bit, guys?
Page 198.
Yes. Can you please
Okay.
mute a little bit so that I can be able to? Guys, please mute. Thank you. So on page, what's this? Page 198, that's transformation. I think it will help you for the other two, what's this? The two questions that I said you should do. So you should also understand transformation because it will definitely be there in the exam. So here in section 2.3, we'll look at the shifting, the reflecting, and the stretching, right? It's either we're stretching it or we're shrinking it, we're reflecting it, and we're shifting it. So on page 198, right, we start with a vertical shifting. So you'll go and read there. So let's say you have a function. What that blue block on vertical shift of graph? It says that suppose that you have C. Now C is a constant, right? C is 1, 2, 3, 4, 5. And then C is positive. So they're saying, suppose that if they say C greater than 0, they just mean that every number, remember the number line from 0, all the numbers that are on the right hand side. So meaning that C is positive. So on that block, they are saying that, let's say C is greater than 0, means that C is a constant. And you have a function y is equals to f of x, right? If you write y is equals to f of x plus c, then it means that you have shifted the graph, this graph, c units upwards. Does that make sense? Guys?
Yes.
Yes, ma'am.
Thank you.
Yes, it makes
Now,
sense.
I want you to focus on this, right? Let me point it out now. The vertical shifting and the horizontal shifting are two different. They have two different like let's say meaning that might confuse you. You see here, you plus. When it comes to the vertical shifting, you plus. It means you are moving upwards, right? You are saying that for every value of y that I get for, isn't that you substitute x here, you get values of y. For every value of y that I get here, I will add by c. So if here I got, let's say 4, the y value was 4 here, and c is equals to 3. It means for the new graph, you will add by c by 3, which will then equal to 7. So you are shifting it upwards, vertically upwards. Now, if you still have like f of x, and then for a value of c greater than 0, y equals to f of x minus c. It means that you are shifting this graph vertically downwards by c units. So you're shifting, let's write it, shift down, shift, let me write shift f y equals to f of x down what by c units. Are we all sorted there?
Yes, ma'am.
Yes, ma'am.
Last yes? I want a last yes. 3 yeses, then I'm fine.
Yes,
Yes, ma'am.
ma'am.
Thank you.
Yes, ma'am.
So let's look at an example, right? We have f of x is equals to x to the power. What am I saying? We won't be drawing such a graph. Okay, before I start with that, do we know what are mother functions or parent functions? Hello?
No.
No, ma'am.
Okay. So mother functions are or parent, okay, some people call it parent functions or a mother function. A mother function is a function that you can use to draw the shifted and the vertically shifted, horizontal shifted graph. So if you know a mother function, then it becomes easier for you to draw a shifted function. Now, what is a mother function or a parent graph of a straight line? Guess. Y equals to what? Guys?
mx.
No, sorry. Y is equals to x. From this graph, you can be able to draw y is equals to 2x plus 1. Then because you will know that this is what? Stretched by 2 units and shifted vertically by 1 unit. I'll show you that. Now, what do you think for a parabola is? Please guess.
Y is equals to
Y is equals to? Y is equals to?
X
X
squared.
Thank you.
Good.
What do you think for the absolute value function is? Hello?
Absolute value of X.
Thank you. What is the okay, I forgot the name of the function. Y is equals to square root of X. And what else would I ask you? So know all these functions. Those are parent functions. For this module, know all these functions. Are we all okay and sorted? So these
Yes,
are parent
ma'am.
functions.
Ma'am.
Thank you. Now with this parent function, so in example 1, they say that you have f of x is equals to x squared, right? That is the parent, they give you a parent function and they want you to sketch u of x is equals to x squared plus 3. Did this, what was the shift of this graph? Can anyone tell me? G of x is equals to x squared plus 3. What happened?
It shifts it upwards.
Yes, 3 units upwards.
Thank you. Vertically, right?
Upward.
Vertical, 3 units
Upwards.
upwards. I might give you something like this, and I might say give the statement in the test, the exam, and then you say this graph shifted. I might ask you what are the transformations, guys? Can you please mute me?
Ma'am, can you please be louder, Nyana, because I can't hear you clearly now. It's like there's a wind blowing.
Yes. Can you mute? If everyone mute, I'll be possible that I think that might be
Okay.
the problem.
Okay.
Yes, someone has their wind. Yes. Can you hear me now?
Yes, ma'am.
Can you hear me now?
Yes,
Yes,
ma'am.
I can hear you.
Yes, thank you. Guys, after answering, please switch off so that we can hear each other. So I'm saying that in the exam, I can give you a function. Let me not say I will. I can give you a function and say, explain the transformation. Like this one, you'll say, it shifted 3 units upwards, or vertical shifted 3 units upwards. Basically, you can do that. So it means that if we're drawing this graph, this is how we're going to draw it. So you're given the mother function or the parent function, they ask you to draw this graph over here. So okay, let me do this. You start with your, okay, I need space. You start with your parent function. And you draw it like this. Isn't that they gave you your parent function? Do you see that?
Yes.
So this is y is equals to x squared. Now we're looking at y is equals to x squared plus 3. So basically what they mean is that they are saying that you are shifting vertically upwards. So every point in the graph will shift vertically upward. Like this point over here will move from 0 and go to 3. This point over here, let's say this was 1, and it will go to 4 plus 3, it will be here. Does it make sense?
Yes,
Yes,
ma'am.
ma'am.
And this point will be here. This point that was here will be here. This point that was here will be here. This point that was here will be here. So then your new graph will look like this.
Okay.
So your original graph just went up. So now this is no longer 0, 0. It's from 3 upwards. Do you see that?
Yes.
Thank you. Let's move to the next one. So the next one says h of x is equals to x squared minus 2, right? So you're given the mother function or the parent function, which is x squared. So then let's draw that. We start with the parabola, the mother function. We know it cuts at the origin. And they say that, can you please explain the transformation? What did it do?
It shifted
2 units downwards. Horizontal.
Downward.
2 units downwards. So we know that this point, let me choose a different color. It means this point will come here. Let's say this was 2. So this will be 2. That point will come 2 units downward. That point will come 2 units downward. Like every point in that graph will do what? Will come 2 units downward. So it will basically look like this. It's the original graph, but we just drag it 2 units downwards. So this is the mother function, f of x is equals to x squared. And this is h of x is equals to x squared minus 2. Are we all sorted?
Yes, ma'am. Loud and clear.
Thank you.
Yes, ma'am.
So that's the transfer. Now shifting horizontally. Going to shifting horizontally. Oh, just torn. Shifting horizontally, you will read that, but I'll just summarize it. I want us to breathe in and out for this one, because then you might add, but you might move to normally your mind will tell you that if you add, you have to move to the right. But if you subtract, you have to move to the left. Your mind will tell you that, but that's not true. But math says that if looking at horizontal shift, right, of graph, what happens? Same. We consider that c is greater than 0. C is a function, no, constant, sorry. 1, 2, 3, 4, 5, half, not negative, but positive, half, 0, 0.5, 0, 0.75, any value that is greater than 0. Now you have a function f of x. They say that if you have y equals to f of x plus c, do you see that I went inside and I wasn't outside? Meaning what I'm saying is y is equals to c times f of x. Whatever value of y you get, you multiply by c. Do you see it's different? In this case, we're saying for every value of x that you were having here, if you say x is 1, then you have to add by c. Do you see the two difference? This is a vertical shift and this is a horizontal shift. Are we making sense, guys?
Yes, ma'am, we see the difference.
No, sorry.
We see the
No,
difference. Yes, ma'am.
no. Here I'm wrong. I'm wrong here. It's y equals to f of x plus c. That is stretching and the other thing. Minus c. So with vertical shifting, we are adding the values of c to every value of y that we obtain after substituting in f of x. Now, for horizontal shifting, what we're doing is we're saying that if x is 1 for f of x, let's add c. So if c is 3, then we'll say 1 plus 3, then we have shifted it. So that is our horizontal shift. Now, if we have f of x plus c, it means that we have shifted the graph y is equal to f of x c units to the right or left? Right
Left,
or left?
ma'am. Left, ma'am.
Why right? I'm getting right. Why right? Okay, we'll see that. Okay, we'll see that later on. Now, please do not confuse. Remember, guys, remember when we had this part here in a parabola? Remember that? Inside the bracket.
Yes.
Yes, ma'am.
Was our C positive or negative? Was our C positive or negative?
Negative.
It was negative. Do you see that C becomes negative? It means that you're going to shift your graph to the left.
Okay.
Remember that.
Okay.
Yes. So if you add, it means that you're shifting your graph horizontally to the left. Do you see that? So y is equals to f of x plus c, it means that you're shifting the graph of f of x, y is equal to f of x, horizontally, horizontal, shift to the left. Are we all together?
Yes,
Yes, ma'am.
Now, if you have y is equals to f of x minus c, it means that you are shifting horizontal to the,
To the right, ma'am.
thank you, because if you take this and say x minus c equals to 0, your x is equal to c. So it means that c is positive, so you're shifting it to the right. Are we sorted?
Yes, ma'am.
Yes, ma'am.
So let's look at the example. Now they say they're giving us a parabola as well, x squared, then g of x equals to x plus 4. Now, I want us to diverge from what we're doing here and assume that this here was a horizontal shift to the right. Isn't that we said to the right first? Guys,
Ma'am?
remember we said this was a horizontal shift to the right, and which was incorrect, the statement that said, right?
It's to the left, yes.
Yes, but I just want to clarify something. Because it's a positive, you see it's a positive inside. And if your original graph is like this, and you forget, remember, you forget that for vertical shifting, when you add, you go upwards. And when you subtract, you go downwards. For horizontal, when you add, you go to the left. When you subtract, you go to the right. Now, I want you to notice this. If you forgot that one and you say, okay, fine, for this horizontal shift, when you add, you go to the right. Isn't that we are saying that when we move to this side, when we move from here, we'll be somewhere here. That's what to the right means, right?
Yes, ma'am.
Yes, ma'am.
You check this is incorrect. It's because, look at the turning point. For this equation, what is the turning point? The coordinate of the turning point.
It's the origin. Point of origin.
For this new equation,
Or the new one.
this one.
Oh,
It's yeah. Okay, before that, I just want to show some points here. I'm not sure if we're on the same
Now
page.
on the equation.
Okay, before that, right? Let me start afresh. I'm saying that, let's remember, I just want you to show you the horizontal shifting, that you don't make a mistake in the exam, right? So what I'm trying to say is, this is what I'm trying to say. I'm trying to say we have f of x is equal to x squared, right? And then a, we have g of x is equals to x plus 4 squared, right?
Squared.
Yes.
Yes, ma'am.
Now, let's say you draw the, isn't that for us to draw, we need to start with the mother function. In this case, it would be like this, right?
It's okay.
Guys, please mute. In this case, it will be like this, right? Are we all agreeing that the f of x will be this?
Yes, ma'am.
Now, let's say you forgot that when you add plus 4, are you shifting it to the left, and you are supposed to shift it horizontally because you are adding to x. Now you're confused. Am I shifting it to the left or shifting it to the right? You're confused. So let's say you shift it, you draw the graph by shifting it 4 units to the right. You're drawing now this graph over here, right? And then you shift it 4 units to the right. If I shift it 4 units to the right, it will be here. Do you agree that if I shift it 4 units to the right? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
But then, now, if we go to the vertex form of a parabola, what is our P and Q from this graph here?
Our Q is 0.
Yes.
And our P is 4.
Is it 4?
Oh, minus 4. Minus 4, sorry.
Negative
Minus
4.
4. Do you see that now? The graph we drew here is incorrect.
Yes, ma'am.
It means that this graph was actually supposed to be this side.
So it shifts actually to the left. Okay. Yeah.
If this is plus, then it's shifted to the left. Because you will say x plus 4 equals to 0, then x is equals to minus 4. If this was x minus 4, then it means you're shifting it to the right because this equals to 0. This is x is equals to 4. Do you see that?
Yes, ma'am.
Thank you.
Yes, ma'am.
Okay, let me not use my finger because if I use it, I press a lot of things. Close here, and save, and here. Good. So meaning that now we have f of x. Oh, the yellow color might not be very clear. So we have going on now. We have f of x is equals to x squared, and they want us to sketch f of x is equals to x minus 2 squared. So is that shifting to the left or to the right? Horizontal left or right?
To the right, ma'am.
Thank you.
To the
Why?
right.
Why?
Because it's a minus, and
It's
if
a
you
minus.
do the x minus, if you do the x minus 2 is equals to 0, you'll get that it's positive.
Thank you. So now this is another function, right? Which is f of x. So we use that, we shift to the right, meaning that every point from here will move 2 units to the right. So this point here will be here somewhere here. This point here maybe might somewhere here. Like all the points, they shift 2 units to the right. What am I saying? My brain is what am I saying now? What am I
Right is the other side, ma'am.
Thank you. Okay, let me breathe. Please mute, guys. I think I'm tired, that's why. So if I hear sounds, I'm not able to. Okay, we start with the parent function. This is the parent function, and this tells us we're shifting the graph vertically to the right. So meaning that from here, we're going to move to this point, and that point will move 2 units to this point, and this point, like just like that, 2 units to that point. Even this point will move 2 units there. So this will be like this. A graph will be like this. So then this will be the graph of f of x is equals to x minus 2 squared. And in the textbook, they'll show you proper because they drew it according to scale on the nice scale. So this is a question that is similar to the one in our work, in our assignment. So example 3. So here they're combining both the horizontal and the vertical shift. So we have y equals to x minus 3 plus 4. Can someone explain the transformation here? Before we explain the transformation, what is the parent function? Y is equals to?
Square root of x.
Thank you. Now explain the transformation. How did they move from y is equals to square root of x to y is equals to that? Let's call this f of x. Please explain the transformation. Yes?
Ma'am, can you
Yes?
please repeat the question?
Explain the transformation. How do they move from the parent function to this function over here?
The graph was moved
Mm-hmm.
bits to the right, and then
It was moved what?
3 units to the right and 4 units up.
Do we all agree with her?
Yes,
Yes,
ma'am.
ma'am.
Thank you. So let's draw the graph. So we have this graph over here, and we know that the parent function is here. So this is the parent function, right? Now this parent function, they say that they move the graph. You can either start with horizontal shifting or vertical shifting, guys. It's really up to you, right? So it's really up to you. So according to this graph was, okay, I need space. Let me start fresh. I need space, so let's draw it like this. My pen changes color here when it wants. So this is the mother function. So this is y equals to square root of x. So you can start whether with the horizontal shift or the vertical shift. So let's start with the horizontal shift. We now want to draw, so we have y is equals to square root of x. Now we want to draw y is equals to square root of x minus 3. It means that we are horizontally shifting it to the right by 3 units. So we start from here and count 1, 2, 3. So we come here, 3 units. So the graph will be somewhere here. Do you see that, guys?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes.
ma'am.
Now, one last shift. We have x minus 3. It means we are working on this graph and we want to vertically shift it by 4 units. So it means that from 0, remember this is 0, so we count 1, 2, 3, 4. So this point will go here at 4. And it will be like this. So this is our y equals to square root of x minus 3 plus 4. Do you see how we were supposed to draw that graph in the assignment?
Yes, ma'am.
Yes, ma'am.
Can I please have 7 yeses from different people?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Yes, ma'am. Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
And 1 yes from a different person so that I see you understand.
Yes, ma'am.
Thank you. So now we are fine with the shifting. It means that you were able to solve that problem properly. Okay, so there's now what we call reflection. Reflecting is either you reflect it over the x-axis, over the y-axis, over the line y equals to x. They'll tell you where to reflect it, and you need to know. If they say over the x-axis, what do they mean? So on page 201, there's a blue box there. I want you to read everything, but it's important. I'll just summarize. The blue box says that if you have y is equals to f of x, the function, right? And then they say there's some transformation that happens, and then you get y is, okay, let's call this f of x, and this g of x, which equals to y, which is equals to negative f of x. Let's see what happens here before we even go to the notes. So this thing of ours, these are y, these are x, right? Originally, they say we get the value of y. Let's say we're substituting. If I put the value of y, let's say I get the value of y to be here, right? And then I get, I substitute y, x here, I get another value of y, which will be there. Right. Now they are saying that here, for the same values of x, let me choose a different color. If I substitute the value of this value of x here, I'll get that value, and then I get the negative value of it. It means this point will be here, and that point will be there. So this is a reflection about what line? Guys?
This is the
X-axis.
x-axis.
Thank you. So it means that if you have y is equals to minus f of x, this is a reflection about, or in, depends on how they say it, about the x-axis or in the x-axis. And our textbook say in the x-axis. Do you see that? Are we all sorted there?
Yes, ma'am.
Thank you.
Yes, ma'am.
Now, if we have y is equals to f of negative x, so it means that when we draw our graph, we know that, okay, so this is y and this is x. We know that our positive x values were here. Okay, these were our positive x values. You substituted and you got these points. now they're telling you that your positive x value negate it. It means that this one will be something like this here. This one will be in the negative x's. These are positive x's, 1, 2, 3. These are -1, -2, -3. So this is a reflection about what line?
The y-axis.
Thank you. It means
Y.
that you are reflecting the graph y equals to f of x about the y-axis. Are we sorted there?
Yes, ma'am.
Thank you.
100.
Now let's go to
Yes,
the
ma'am.
example. So we have f of x is equals to minus x squared, right? Where do we start? They say sketch the graph of each function. Where do we start?
We started our parent, what is it? Parent function, which is x squared.
Thank you. Guys, if you know your parent function, you'll be able to sketch the graphs. Otherwise, you'll waste time by substituting values 1, 2, 3, and drawing a table and trying to draw the graph. So we know that our parent function, let's call it g of x, is equals to x squared, right? So if we draw our parent function, it will look like this, right? So this will be g of x equals to x squared. Now, what is the transformation here? What is the transformation from the parent function to f of x? What happened?
Didn't it shift downwards? Maybe the side it's gonna be the opposite. It's gonna look downwards because of the
What do you call
negative.
it?
Reflected. Reflecting about
Twice
the x-axis.
Thank you. It's
Okay.
reflecting above the x-axis, not shifting. So the x-axis, they act as a mirror. Do you understand? So if you you can try it even on a piece of paper, right? If you draw this graph and fold at the x-axis, and then when you have folded, try to draw the graph on top of, I don't know how to explain it, if it makes sense. So you have a piece of paper, you draw this, what I've drawn here, and then you fold it on the x-axis. After folding it, isn't that it will be closed? Then on top of the parabola, you try to draw, scratch that graph, and then open the paper. Where you see the image of the scratched part, you draw it, you see it's a reflection of that. I don't know if it makes sense. Does it make
Yes,
sense,
ma'am.
guys?
You are,
Sense.
you're
Yes,
making
ma'am.
sense, man.
Yes,
You are making
sense.
sense, ma'am.
Mhm.
Yes, that's good. So you see it's a reflection of that. If you don't remember the reflection about the line axis, but it will also help even when you are doing an inverse function. They used to show us like that. You draw and then they say reflected about this line. So you draw that line, you fold the paper, you scratch. When you open the paper, where there's a scratch, you just draw with your pencil and you find the inverse of that function. That method really works. So the reflection about the x-axis, it means that our new graph will just be like this. Mirror image of that. Exactly this graph, but on the other side. So this will be f of x is equals to minus x squared. Are we sorted there?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now I wanted to, oh no, before that, there's another one. G of x is equals to minus, no, square root of minus x. Where do we start?
The mother function.
What is the mother function? Let's call it f of x.
It's the root of x.
Thank you. F of x is equal to the root of x. So what do we do with the root of x? What transformation happened to get g of x? And we know that the root of x is represented by this graph. What happened here to get this? What happened?
Isn't it reflected on the x-axis?
Is the statement true or false?
Ma'am, it's a reflection of the what?
Okay. Let me show you something, right? Sometimes the value might even tell you where the graph is in a quadrant. Okay. Here, do you see here it's positive? Okay. Okay, before I do that, this is a reflection about the y-axis, right? So meaning that it will be like this. So this is g of x, and this is f of x. Are we all okay there?
Yes, ma'am.
Okay. Now I want to show you something. Please mute. I want to show you something. So we have y equals to minus square root of x. We have y equals to square root of x. We have y equals to square root of minus x. We have y equals to minus square root of minus x. So this is, if you reflect, so this is something called reflection about the origin. Basically, this where you reflect about the x-axis, then you reflect about the y-axis. So this is reflection about the origin. But let's not look at that. Now, if it sometimes confuses you, right, you can take this example and try to figure where you are reflecting. What do I mean by that? I mean that you come here and do this. Remember, we have quadrant 1, isn't it? Quadrant 2, going back to our high school, quadrant 3 and quadrant 4, right? This is our x, this is our y. We know here x is positive and y is positive. Here we know x is negative and y is negative, positive. Here we know that x is negative and y is negative. Here we know that x is positive and y is negative. Are we all together there?
Yes, ma'am.
Good. If you're looking at outside here, let's start with the mother function or the parent function. Do you see that y is positive? Guys,
Yes,
do you see
ma'am.
that y is positive? And then
Yes,
the x
ma'am.
inside is also positive, isn't it?
Yes.
So where is the
Yes, ma'am.
x positive and y positive in the first quadrant? It means our graph will be here.
Yes.
So now this is our mother function. Now to help us understand where the reflection happened is, let's go to this one. We said this is a reflection about the what?
Y-axis.
Y-axis. Okay. Now let's not look at, we want to draw this graph, right? Let's make it green. The y is negative or positive, guys? Please mute.
To the left.
Okay. So is y positive or negative here?
It's negative.
Is x positive or negative here?
Positive.
So where is x positive and y negative?
It's on the second quadrant.
Where is y negative?
No,
and
y
x
negative.
positive?
It's positive. It's on the fourth quadrant.
Fourth quadrant.
Yes.
Now, if we look at our notes, we said this is a reflection. This is a reflection about the x-axis.
Mm-hmm.
Do you see that?
Yeah.
Yes, ma'am.
So
Yes,
this
ma'am.
is true. Does it make sense?
Yes, ma'am.
Yes, yes.
Okay, please mute. Let's try another one. Can you please mute? Thank you. Let's try this one. Is our y positive? Give me, you have to give me x and y. You say x is this, y is that.
Y is
From this,
negative.
yes, x is negative. So y, we're saying here y is positive because there's a positive there, and x is negative because it's there. Where is y positive and x negative?
Second quadrant.
Second quadrant. According to our notes, it says that if you have y equals to f of x negative x, this is the reflection about the y-axis. Is it true? Let's see. We're taking this, we're reflecting about the y-axis. Do you see that?
Yes, ma'am.
Yes, ma'am.
So this one, y is negative, x is positive. This is this. Okay, how do you draw this thing? Reflecting about the origin, it should be something like this. I'm not sure if I'm drawing it correctly, but I think it will be something like this. Yes, it will be something like this. The reflection about the origin. Do you see that? So this one will help you if you forget on whether to reflect. When they ask you reflect this function about the x-axis, then you can try to use this one and say, okay, fine. If I reflected about the y-axis, it means that x has to be positive, y has to be negative, that. And then it will help you solve the problem. Are we sorted?
Yes, ma'am.
100%.
Loud and clear.
Thank you. Now, vertical stretching and shrinking of the graph. When you stretch something, does it become thin or thick?
It becomes thin.
Thick.
Thin.
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 Thank you.
Thin.
Yes. So it means that let's look at like that. If it doesn't happen to our graph, it means, guys, math is also logic. Think about it, and then it has to make sense. Because if you're stretching something, it has to be what? It has to be thin. If you're stretching something, it has to be thin. So let's see if that is true. Now, vertical stretching and shrinking of a graph on page 202. That is page 202. They say that if, let's say, you have this graph, f of x, it means what did you do to the graph of f of x? So they are saying that if you have c is equals to, c is greater than 1, it means you stretched the graph of f of x. This is stretched the graph of f of x vertically by a factor of what? Of c. Am I making sense?
Yes, ma'am.
Yes, ma'am.
And then if c is between 0 and 1, it means you have shrinked it, right? By a factor of
Yes. See.
Thank you. Are we happy then? Let's look at an example.
Yes, ma'am.
Yes, ma'am.
A. So we have g of x is equals to 3x squared. Now, where do we start? Parent function. Now let's draw the parent function. So this is our parent function. Now this is f of x equals to x squared. Did we vertically stretch it, or did we vertically shrink it? Guys?
It's shrink, I think.
Stretch.
Okay. Before that, let's go there. Before you answer that question. So I want us to choose 3 points here. Okay, this one will not change. Let's choose 1, 2, and 3. So f of 1 is equals to what? 1, isn't it? F of 2 is equals to what?
4.
That is 4. And f of 3 is equals to 9, right?
9. Oh, yeah.
Yes.
So let's say this is 0.1. This will be equals to 1. And let's say this is 4. This is 2. So this will be equals to 4, right? And this is 3. And this is equals to what? Equals to 9.
9.
So same applies this side. So meaning that this will be -3 because it's a parabola. And this will be, sorry, the x value, what am I saying? This is 1, 2, 3. Okay.
That's
Let me
negative
erase
1, 2, and 3.
So this will be -1, somewhere here, -1, -2, -3,
Yo, it's clean your baby
right?
pot.
Please mute, guys.
Yes, ma'am.
Thank you. Now they are saying that this is the original function, isn't it? Now we
Yes, it
want
is,
g
ma'am.
of x, so we'll choose the same value. So we want g of x, but we choose 1, 2, 3. So g of 1 is equal to 3 times 1 squared, which is 3. G of 2, which is 3 times 2 squared, which will be equals to 4 times that will be 12. And then G of 3, it will be equals to 3 times 9, that will be 9 is 27, right? So remember, let me choose a different color. Remember, this is the original function. So the new function says that if x is equal to 1, right? I'm no longer at 1. I'm no longer here, but it starts here. So the graph starts here. If x is equals to 1, I'm no longer here. I move, I go to 3. So it means the new graph will be here. If x is 2, I'm no longer here. My x will be 12. So it means I'll move here, somewhere here. If x is 3, I'm no longer here. I move to 27. Same applies to this one. If x is 1 here, -1, it will give me -3. So I'll be here. If x is 2, it will give me -12. So I'll be, sorry, not -12. It will give me 12, sorry. If x is 2, I'll get 12. And if x is negative, okay. If x is -1, I'll get +3. If x is -2, I'll get +12. If x is -3, I'll get 27. It means I'll be somewhere here. So let's draw this new graph. Do you see that? So that's the new graph. Did we stretch it or did we shrink it?
Shrink.
We shrinked it.
Because we said when you stretch something, it becomes what? It
Thin.
becomes thinner.
Thinner,
So it means
yes.
that for all values c greater than 1, that is 2, 2.5, 3, 4.5, like all those values greater than 1, we are stretching the graph. So it means that the new graph will be thinner than your original graph. Does it make sense?
100%.
Yes, ma'am.
Yes, ma'am.
Thank you. So it means shrinking, it might make it thicker. So if you see those bouncing balls, gym balls, if you sit on it, it becomes thicker, isn't it?
Yes, ma'am.
Yes,
Thank
ma'am.
you. Or a balloon, if you try to press it, it becomes wider or thicker. Not thicker, but wider. Let's say wider. Let's see if that is true. So they are saying that if we have f of c of f of x, right? And your c is between 0 and 1. It means your graph will be wider. So basically you're shrinking it, right? So let's see an example. So we have f of x is equals to 1/3. So we have x squared. Now we know that the first part where we have to start is always on the, so the first part where we start is always on the mother function or parent function. So our parent function is f of x is equals to x squared. So let's draw that. So this will be x squared, right? X squared. Now, just to take values, right? Let's take, let me see what values can work for here. Let's take 1, let's take 2, let's take 3 still. We know that f of 1 is equals to 1, f of 2 is equals to 4, f of 3 is equals to 9. Now we take the same values and substitute for h. So f of 1 is equals to 1 over 3, that's 1 squared, this is 1 over 3. Then h of 2, this is equals to 2 over, sorry, f of 2, that's 1 over 3, 2 squared is equals to, that is 4 over 3. Then h of 3 is equals to 1 over 3, that's 3 squared, which is equals to 9. This gives us 3. So we said that at point 1, okay, remember we started the origin. At point 1, let's make this 1. Our graph will be here at 1. At, let's say, 2 is here. At 2, our graph will be at 4. Let's say at 3, our graph will be what? Will be 9. Same applies at -1, our graph will be 1. At -2, our graph will be 4. At -3, our graph will be what? Will be 9, -3. So let's substitute these values that we have obtained and see what happens to our graph. Choose red color. So they're saying at 1, where's our graph? 1 over 3. Where's 1 over 3? Is it over 1 or below 1? Guys?
Below 1, ma'am.
Yes. So it means 1 over 3 will be some, okay, this is the origin of the graph. 1 over 3 will be somewhere here, isn't it? Where's 3
Yes,
over
ma'am.
4? 3 over 4 is 1 comma something. Do you see that?
Yes, ma'am.
So 1 comma something will be somewhere here. 1 comma something, just above this one here. And then 3 will be somewhere here because this is 4. So let's say 3 is here. Same applies this side. Now when we draw the graph, guys, mute. Please mute. Do you see when we draw the graph is now wider than the original
Yes,
graph.
ma'am.
Yes,
So
ma'am.
means that if you have y is equals to c f of x, ne? And then c is greater than 1, you are stretching it. So the graph will be. Now, if c is between 0 and 1, it means it becomes, guys, please mute. If c is or 0.3 or something, it means that you are what? You are actually shrinking the graph because you are pressing it down. So it becomes, you are shrinking it, so it becomes wider. Now, let's look at example 6. So we're going to look at example 6, and I want one of the homework is to go and look at horizontal stretching and shrinking. Next, guys.
Okay, ma'am.
Yes, ma'am.
Please mute. Let me explain. Let me draw this graph so that we can. I think we had enough for today. Example 6. Example 6, they are combining everything that we did. So f of x is equals to, you will tell me if I'm -2 of x minus 3x squared. So like I always say, start with the mother function. Let's call it g of x, which is equals to x squared. So I draw the mother function here. So we are combining everything, right? So this is the mother function. This is x squared. So it means that we started, let's say y is equals to x squared, right? And we want to draw this one here. You can start any way you want, basically, and you'd end up getting the same graph. So now I want to draw y is equals to 2x squared because of these two, right? So what is the reflection there? Please remind me, what is the reflection there? If I multiply by 2, what am I doing to the graph? Right? If I multiply it by 2, what am I doing to the graph?
You are shrinking it.
You're stretching it, ma'am.
Shrinking or stretching, which one? There are two. We are stretching it by effect of 2 because we said c greater than 1. We are stretching it. It means that our new graph will be like this. So this will be y equals to 2x squared.
Stretching.
Thank you. Now, I'm done with this 2. I want to do what's inside here. So if I'm going to do y is equals to 2x minus 3 squared, what am I going to do with this purple graph? What transformation am I doing with this purple graph?
Ma'am.
Yes.
You're shifting it horizontally to the right.
Thank
Yes.
you. By how many units?
3
it's
units.
important you mention units. 3 units. So it's from here. 1, 2, 3. Let's say 3 is here. So the graph will be there. The purple graph. Remember, we moved from the red graph to the purple graph. So this is graph 1, this is graph 2, and this is graph 3. So I'm now done with the inside part. So I want to move from the green graph, which is y equals to 2x minus 3 squared. I want to add by 1. What does that mean?
Vertically shifting the function by 1 unit up.
Okay, so it means that I'm taking the same unit. I'm going, remember this is 0, x is 0 here. So I'm going 1. So this is 1. So this is my new graph. So this is graph number 4, which is y equals to 2x minus 3 squared plus 1. Now, there's a negative here. So this is y equals to minus 2x minus 3 squared plus 1. What am I doing to the graph now?
Reflected upon the x-axis.
Thank you. Remember now the new line of x-axis is this one. Here. Because my graph is here. So we're reflecting it above the x-axis. So the graph will face this way. You see that, guys?
Yes, ma'am.
100%.
Yes.
There you go. So that's what you were supposed to do in your assignment, basically.
That assignment, yo, right?
Huh?
That assignment gave us flames shame, yo.
But now, can you answer it now?
Yes.
Yes,
Yes,
Good.
ma'am, we
That's
can.
why I said let's
Yes.
attend discussion classes. You didn't want to attend discussion classes. Now I want you to be prepared for the exam.
Ma'am, when are we
Yeah.
writing the exam?
Wait, what?
When are we writing the exam?
When or where?
When?
Normally the exams starts in September. So it means that we have October, we have July, this whole July and August to really work hard on the discussion classes.
Yeah, that's true.
Yes. So hopefully our exam is there. Isn't that they will give us timetable? I hope our exam is in October so that we have July, August, and September to cover everything.
Me too, Mama, because I'm slightly behind, eh?
No, it's fine. We'll cover. If I say right now, I want 10 submissions from you guys on those questions. If you give me 10 submissions, then we have another discussion classes. If I get more, for, let's say right now, 19 people attended, right? If I get, let's say, double the number of people who attended, we can have 2 discussion classes even per week. So it would depend on you, how serious you are.
Ish.
We are serious for you.
Then we are serious.
More especially on
Ma'am, is there-
functions. Yo.
We have.
Ma'am, is there a group?
A group of what?
A group where we communicate across students or something.
Why don't you create a group? Why don't you create a group?
Okay.
As long as you're not communicating answers, just create a group and then you can send me the link and then I'll tell people to join the link. And then you discuss.
Okay, ma'am.
And you discuss the questions on what to do.
Okay, ma'am.
Thank you.
And it's gonna be helpful, hey?
Yes. And if there's a problem that you encounter in the group, then you send it to me. And then we solve it, and then basically it's going to be helpful. It's because I told you, let's start the discussion classes. No one was coming through. So because of the 3 people in the first discussion class, that's why we continue. Now the horizontal stretching and shrinking, it's your homework. If you don't understand it, I will touch on it next week. So yes. Now, whether
Next week when?
Yeah, I'll tell you.
Okay.
I'll tell you. Because sometimes we might end up having classes later on.
Okay.
So that we cover, yes. But based on, remember I said based on your submission, we will have a class or not. So odd, even odd functions. So they're saying they on page, what's this? On page 205, they say if you are given a function and you substitute, okay, so let's say f of x, what am I saying? I'm tired. Let's close. Y is equals to f of x. So they're saying that a function will be even if you substitute, if your f of negative x is equals to f of x. One example of an even function is what? Is f of x is equal to x squared, a parabola. Because f of x, negative x, is also x squared. So that's an even function. For an odd function, if you're given a function, odd function, it means that f of negative x, then it will be negative of f of x. That's an odd function. And then on, sorry, a function can either be negative, a function can neither be even or odd. Some functions are not even and then they are also not odd. So on page 204, they'll tell you that an even, there's a nice statement, says the graph of an even function is symmetric with respect to the y-axis. Is that true? Yes, the parabola is symmetric with respect to the y-axis. Now, the graph of an odd function is symmetric around the origin. And that is your cubic graph, which is symmetric. What's this? It's symmetric around the origin. That is page, what's this? That is figure 12 and figure 11. So you read your notes, and that's where we're going to end. So at the next week, remember I said, you submit, and next week we cover combinations of functions, then I think we're done with assignment 2. Is that okay?
Okay, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Ma'am, can I ask something?
Yes.
I keep hearing you mentioning page numbers. Is there a prescribed book?
Yes,
Because I don't have a book.
you have to buy it.
Okay.
You
The
need
name
to
of
make
the
sure.
book.
It's under additional resources, is under prescribed book, is also in the tutorial later.
The one with Stuart, and there are 3 authors.
Yes, that one.